So here we are. So Java main class. So here is working. The age value is 10 and the new age value is 100, getting it from this method in creation class. Alright, so the next thing we're going to do now is the next solution that I spoke about earlier, that we're going to put both the main class and creation class in both in the same package, and we'll see how it works. Remember, I told you about the default modifier, that if we're going to declare a class to have no modifier, then automatically Java will give it a default modifier. And what it means is that only classes within the same package can access the class or the variable or the instance. Alright, so here I've just edited this. I'm going to save it. Let's go back to our environment. I have that summary, SoftSchool Java. Okay, week2 day1. Okay, we'll delete this. Okay, yeah. So okay, there we have it. So I'm going to change this. I'm going to remove it from here and put this here so that we'll have we'll both be in the same package. Okay, so the next thing will be to compile. So here I have let me clear the screen. Then I'm going to compile the creation class. Okay, great, done. So let's see. We have com.softschool.week2 day1. The creation class is there. Then we're going to compile main class also to be in the same package. So I'm going to go main class java. Okay. Alright, so that's it. So again, if we look at the in week2 day1 in com SoftSchool Java week2 day1, we have the creation class and you have the main class there. So we're going to compile this main class. To avoid the confusion, I would like to delete this. Alright, so that we compile just the one we have in our package. Alright, so to compile that, we go Java that's in com dot SoftSchool dot week2 day1, right, that main class. That's what we're compiling. Great, see, it works. So that's the two solutions you have when we're dealing with the default modifier. Default modifier means that only classes within the same package can have access to the class, the instance, and the method. Okay, or it will be declared public so that classes in other packages can also have access to it. Alright, I hope it's clear. Anyway, in our WhatsApp group, we're going to discuss more about this, and if you have any question, we'll discuss it in the WhatsApp group. Okay, so we're done with this modifier. Now we'll look at other interesting modifiers in Java. As we go along, I will tell you my favorite modifier in Java. Now we're going to look at the final modifier. What does final means in Java? When you declare a variable, a class, or a method with final, what does it mean? So let's discuss this final modifier. Okay, I will want to keep this and create a new class for this example. I'm going to call this class my modifier class, public class modifier. Okay, then I would say public. I don't believe now you know why I'm typing this public, and now you should have some conscious feeling about this public modifier now. The public void, let's say public void compute, excuse me, compute let's say compute average, have you can type this morning, can't type. Alright, so Alright, so I'm going to save this as a modifier class, or let me call it a modifier example one, or example. Fair. Okay, I'm going to save this. Not here. Alright, I'm going to save it here. Java. Okay. So we have a class. Then I'll let you create two variables, numbers, int, call it age1 is equal to 36. No, not that. Age1 equal to 36. Then age2 is equal to 14. Okay. All right. Now we have this class called modifier example. We have two instances declared here, age1 and age2, and then we have public void compute average. I'm going to compute the average of these two age is okay, and here I will do this. I'll call it double average is equal to age1 plus age2 divided by 2. Now I want to believe you know why I had to put bracket here, because I want this to be performed first, and then after performing this I want this to be done. Now remember we discussed about operators and how Java resolve operator computation when we have it in a statement like this. If you've forgotten, you can watch the week 1 day 2 videos that will give you a lot of insight into operations in Java. We've discussed that in our previous class. Alright, so this is average, and then I'm going to say system.out.print line with like the average age of let me show you one more thing we can do with printing in Java. There's a printf in Java, okay, and it allows you to use interpolation when you're printing out in Java. So you have the average age of, I can do something like percentage sign I. If you're used to C programming, or if you've done C programming before, this should be somewhat similar. The average age of this and percentage sign I, or you can use D, is percentage sign I again double. Okay, I'm going to use D, or you can use F. Okay. Now here I'm going to put age1, comma, age2, and average. Alright, so let's go to our class. In that class, the main class for this example. Let me save this. Then here I have public class modifier main modifier. I'm calling it the main modifier because this is where we're going to have our main class. Public static void main string okay. Alright, I'm going to save this as our main modifier class. Save this .java. Okay, then I'm going to create an object of this class here. Is equal to modifier is equal to new modifier example. Alright, so here I'll say modifier dot calling this method compute average there. Okay, so before I begin to introduce the final, I would want us to quickly compile this program and see what the output looks like, then we'll begin to make modification and adjustment to it to explain what that final modifier does, or its effect in class, method, and variable. Okay, so let's go back to our environment. I'm going to clear the screen. Okay, now I'm going to compile java main modifier .java. Now I told you earlier that if you compile the main class, it will compile every class that is associated with it, so that we don't have to compile everything one after the other. So let's see. Alright, good. Compile fine. Then we go java main modifier. Java main modifier. Okay, we have an error somewhere. Unknown format conversion, exception conversion I. Okay, it's complaining about I. Change this to D. Change this to D. Okay. Clear the screen. Compile again. Alright. Okay. So we have the average age of 36 and 40 is 38.0000. We can also make some adjustment to it and say, hey, here let's do a dot 2f, means that we just want it in 2 decimal places. Okay. I'm going to play the screen again, compile, then okay, so we have 38.00. Alright, so maybe some, as we go on, I will come back to revisit this method to show you how we can have different interpolation for displaying output in Java. Okay, now let's look at final modifier. Now here, if I say, hey, age 2 or age 1 is equal to, I want to change the value of age 1 from 36 to 46. Okay, now let's see what the effect would be. I'm going to remember this is our output from a previous program before I edited the age 1 value. Now I'm going to say compile again because we just made some modification. Then let's see what the output will be. Okay, now I have the average age of 46 and 40 is 43.00. Now okay, you see that the value was initially 36, now it's 46, and 40, the value is from 38 to 43, so there have been some changes. Now if I declare age 1 to be final, final, what does it mean? Now the truth is this, I'll tell you what final does. Final means constant in Java. Final means constant in Java. It's used when you want to declare a constant variable, meaning that a variable whose value will not change during the course of the program. Okay, what this means is that this value 36 assigned to age 1 is a constant, and we want this value to remain throughout the program. So in any attempt to change it anywhere in the program, it will flag an error. So this is supposed to flag an error saying, hey, this is a final variable, why are you trying to change the value? Or should I say, this is a constant value of variable, why are you changing the value? Is what we should get as our error message. Let's check it out and see. Okay, again I'm going to compile since we've made some modification. Yes, did I save it? Yes, I saved it. It's blue, so compile. Yeah, you see that modifier example .java line 8. This is it here, saying error, cannot assign a value to final variable age 1. You see that it's a constant variable. The value should never change during the course of the program. Okay, that's the complaint there. So final is used to declare constants in Java. Maybe you're having a program and you need to declare a constant that's going to be used throughout the program. You should declare that variable to be final. Final, like you declare a program and you have pi, which is 3.142. 3.1142. So you assign this value to a variable. You should declare a variable final because this is a constant value in Java. I mean, constant value is used in computation. Okay, so final is used for declaring constants. and of course that value should not change during the course of the program. But here too, if I declare this to be 50, this should work because h2 is not h2 isn't a constant. It is not having a final modifier, so everything should work. 36 and 50 is 43.00. yeah, that's it. All right, so that's constant with variable. Now how does final affect method and class? If you say final is used to declare constant, then how does it affect method and class? Now I'm going to see an example now. Yeah, I'm going to create a new class. I'll call it pub public class example, and I'm going to call it example modifier child extends. We discussed this extend in the previous class. I mean in earlier video, or earlier in this video, I told you what extend means. This is the parent class, this is the child class, this is the super class, and this is the sub class. Okay, now I'm going to come back to this place and I'm going to copy this from here to see. I'm going to put it here. Then I'm going to make some adjustment to it. Before then, let me please save this. Save it as modifier child.java. Alright, so I'm going to make some modification to this. Okay, before that, okay, let's go on. I'm going to say this is equal to 150. Okay, and then we're going to divide by, I want to divide by I'd like to add another one to it. I'm going to declare that one here, saying age h3 int h3 is equal to 40. Alright, so I'm going to go like plus age 3, so I'm going to divide by 3. Okay, so the average age value of this and comma this is so like h1, h2, and age h3. I got messed up there. Okay, h3 is the average value. Okay, all right, so this is it. Now I'm going to, what we just did here, like I told you before, is we just overwritten this class. Yeah, so I'm going to create an object of modifier child here. Instead of modifier example, I could like modifier child, new modifier child, modifier.compute average. Now it's going to call this method. It's not going to call the method from this class, no, because this method is available in the child class, so it's going to call this method. Now the variable h1 and h2 will be coming from the super class h1 and h2. Okay, then when it gets to this method, it will actually call this method in the subclass, then compute this, and then we're going to get output as this. All right, so let's see how it goes now. All right, so I'm going to play the screen, then I'm going to compile. Okay, then alright, so we have the average age of 36, 150, and 40 is 75.00. So you see, it's not actually calling the superclass method. Now if we look at this carefully, I don't think this computation is completely correct. I'm expecting to see fractions here. Let's try and tweak it to give us the true value. Okay, here I'm just going to convert one of these to double. We talked about casting. If you still remember, you can watch the other video and you see why I'm doing this here. So convert this to double, then convert this to double. Okay, cast this to double. Yeah, like that. If I just do one, it's just okay, because automatically everything will be done in double. But let me just make it 2. Okay. Alright, so let's compile again and see the effect. Java. Okay. Alright, this is more like it now. So 75.33. Good. Okay. Now, we have this method complete average, which was overwritten by this class from the modifier example. Now here I am going to declare this to be final. Remember I told you about modifier, so that it could be declared in any way. Like I can try to put this before the public. Okay, it's still acceptable. Okay, so either before or before after the public, but for simplicity and for readability and to stick with convention, we go the access modifier first before other modifiers. Alright, now doing this means that this will be declared, this method will be declared constant, meaning it will never and should never be overwritten by the subclass. Okay. Alright, so what is the method? That is a constant method. Constant, it stays. Okay, and in the subclass this should never be, this should never exist. Okay, the subclass should never try to override that method. Yeah, that's what it means. Okay, so I'm going to show you, clear the screen, and I'm going to show you what it means. Okay, go like Java main class. Alright, you see that exception in thread main class modifier overrides final method compute average. Okay, which should not be. Okay, so there's an error there, so it's saying that we're trying to override a final method. So when a method is declared final, means that it should never be overwritten in the subclass. So I'm going to take this out. Okay, and save. Then I'm going to come back again to compile. Then everything should work fine. Yeah, everything works fine. Okay, so that is the final. Now what about if I say, hey, the class public final class modifier example? What does it mean? It means that this class is a final class. Final class. Okay, what it means is that this class is a constant class, a constant final, a final class, meaning that this class should never be extended. Okay, it's not allowed for any subclass to extend, or any other class for that matter, to extend this class. So in this case, when we have public class modifier child extends modifier example, it means this should never exist anywhere in your program, because the class is a final class, is a constant class. That's the end. Okay, no extension allowed in this class. Okay, so let me save and let's see the what we're going to get in the output. Clear the screen, then compile again. Alright, so it'll be like Java main class. Again, you see that Java.lang verify error cannot inherit from a final class. You're not allowed, nobody's allowed to inherit from a final class. Means a final class should never be extended by any other class. Okay, that will be final. So see the final modifier, how it can be used in variable, for a method, and for a class, and how it affects your program. Okay, so I've just removed the final. We'll recompile again and let's execute. There we go. Okay, so that's it. So again, so if I say this is final, it means that, hey, this should not be there. I should remove this from there. It shouldn't be there. Okay, and means that this class is standing on its own. This class is not dependent on this class, meaning that these variables, variable 2, variable 1, and variable 2 must be declared within this class. Otherwise, we will have an error, because there is no link between this class and this class. There's no link, no inheritance, no link. Okay. Alright, so let's continue and let's pick the next modifier. So we're through this modifier. Now the next modifier is the abstract modifier. Before I talk about the abstract modifier, I want to quickly talk about the static modifier. Let me use this opportunity to take out the static modifier so that I can use an example to explain these modifiers. Alright, now for the static modifier, if you are very observant about the program we'll be writing, you discover that we've always used the static modifier here in our main class. Yes, you wonder why, what's the issue with this static modifier. Okay, now we're going to look at it now and see what up with this static modifier. Okay, so here in this class we have final, we have age. Now if we go into this place now, I will say system.out.println modifier. Just lazy to type. I will just be doing copying and pasting. Modifier dot age1. Okay, so I'm going to say concatenate the value of age1 is the value of age1 is that. Okay, so I'm going to compile this class. Let me take this out so that it doesn't affect the output. So alright, so let's clear the screen. Now here I'm going to compile it. Compile java main class .java. Okay, now I'm going to execute this program. So we go like the value of age1 is 36. Okay, which is correct. The value of age1 is 36. Alright, so remember we still have our final there. Now okay, this is the class. Okay, this is the object from the class. Now if we do this, I copy this from here and I replace it with this, saying hey, I don't want to create an instance of that class. I just want to execute, I just want to call out that variable. Okay, I just want to call out that variable. Let's compile. Of course, we're going to get an error. Java. Okay, yeah, we have it. Non-static variable age1 cannot be referenced from a static context. Okay, now this is what I want to bring out now. Now trying to okay, in fact there are two issues we want to resolve here. The first is the fact that whenever you have a static block, variables declared outside the static block must have the static modifier. Okay, so to resolve that issue, I'm going to put static here. Okay, remember you can combine multiple modifiers, but we can only have one access modifier. If I put public here, it's also valid, but for now I want to leave this blank. Remember, I'm going to have a default modifier here, which of course meaning that this variable can only be accessed by classes within the same package. Now because I don't have any package declaration up here, it means it's going to be using the current folder as a package, and this also will be using the same current folder as the package, so they will both be accessible. Okay, so I just started modifier to age1, and here I have modifier the age1. Okay, so compile again. The error should go. Yes, no more error. Then you have the value of age1 is 36. Good. Now another interesting thing I want to tell you or show to you is this, that when a variable is given the static modifier, that variable can be accessed using the class name or the object of that class. Now this is the object of the class. Okay, now I'm going to go like this is saying the value of age 1 is okay. The value of age 1 from the instance is, and the value of age 1 from the class is okay. That's so that we can have two values coming out, so we're going to be able to differentiate them. I'm going to save this. I'm going to compile and clear the screen. There we go. Java. Alright, so yeah, I'm going to compile and execute now. Good. So the value of age 1 from the class, see, okay, is 36, and the value of age 1 from the instance is 36. Now what I'm trying to say is that whenever a variable is given the static modifier, that variable can be accessed using the class name, okay, or an object of the class, an object of that class. Okay, now remember we're using the child class. Now this is possible because this is the child class. Now we don't have the age 1 yet. Now why it is possible is because the child class extends the modifier example class, like the mother class, so that's why it's available in the subclass. Okay, now something I want to bring out here is the fact that whenever a static, or if I say that, or okay, let's go on, I'm still going to say it. Whenever a variable is given the static modifier, it means that, like I said earlier, that this variable can be accessed using the class name or using the object from the class. And also I want to let you know that whenever a variable is given a static modifier, there is only one copy. There is only one copy of this variable, just one copy, meaning that if there's any modification to this variable by anybody or by any instance, that value will become modified for all the instances. Yeah, let me show you what I mean. Now let me do this. Say the static isn't there anymore. Okay, now I'm going to create two instances. Okay, this is modifier 1 and this is modifier 2. There are two distinct instances, so I'm going to go like modifier 1 to modifier 2. Okay, not bad. Modifier 2, then modifier 1, then age 1. Okay, so I'm going to say value from modifier 1, okay, and the value from modifier 2, modifier 2. Okay. Okay, let me use h2 instead. Let's use h2. I'm going to use h2, which is 40. Now the reason why I'm going to use h2 is because this is declared final. I don't want to change it, and final means we cannot alter this value. Age is constant, so this is not constant. We can always change this value. That's why I want to use h2. Alright, so we're going to compile now. I'm going to see the effect, and I'm going to make some changes to it. Okay, I'm going to clear the screen. I'm going to compile again. Alright, so yeah, so the value of age 1 from the modifier 1 is 40, and the value of age 1 modifier 2 is 40. Okay, so they're both the same. Now actually we're using h2, so I should put this as 2. Now what I'm going to bring out here is this. I'm going to say modifier.h2 is equal to 20, and modifier 2.h2 is equal to 30. Yeah, so now the app we expect that this will display 20 and 30. Yep, let's see. So I'm going to compile again, then execute. Great. Now the value of h2 from modifier 1 is 20, and the value of h2 from modifier 2 is 30, because this object changed the value of its own h2 to 20, and this object changed its own value of h2 to 30, and they are distinct, independent of each other. Okay, what this one did to h2 is actually different from what this object did to its own h2. So they're about 20 and 30. Now we see here 20 and 30. Now, but when h2 is given the static modifier, what happens is that, like I said earlier, this can be accessed using the class name. So I can say modifier example dot h2. I can also say modifier 1 dot h2. But the interesting thing there is the fact that there is only now one copy, just one copy of h2, meaning that if I have multiple instances of h2, or if I say if we have multiple objects from this class or a subclass, and there's modification to that variable h2, is going to affect all the objects from that class. Yeah, so now in doing this, what this means is that the last object to modify h2 is modifier 2 to the value 30. That means modifier 1.h2 will be 30, and modifier 2.h2 will also be 30. Alright, so let's compile now and see the output. Again, I'm going to clear the screen, CLS, or no, I shouldn't clear the screen. I want us to see the output and compare them. Alright, so that's, see that 30 30 30 30, no more 20 30, but now 30 30, because modifier 2 was the last object to change it, and change it to 30. So both modifier 1 and modifier 2 will both have the same value, because that variable h2 is having the static modifier. Yeah. Alright, so again, if we do this, if I say modifier example, or if I say this modifier child dot age 2 is equal to 10. Okay, now because this class is the last change that I perform the last change on this static variable h2, every other instances will have 10 as its value for h2. Okay, so here again, compile and execute. See that 10 10 10 and 10. Good. So that is the function of the modifier static with variable. Now, what happens if I say a method is static? Static. Okay, the rule is this: when a class, or when a method is declared static, it means that there is only one copy of this method, okay, that will be shared by all the instances of that from that class. Okay, then let me comment this out and use another example. Okay, all right. Now, what this means now is that I'm going to copy this out so I can use the example here. Okay. Okay, the first example to say here is that when a method has a static modifier, the first rule is if a class will extend this class, like we have it here, which this class is extended, and if it's going to override this method, then like we have it here, also because it's having a static modifier, this must also have the static modifier, otherwise we're going to have an error. Okay, static modifier must also extend the static modifier. So if we leave this the way it is and we go ahead and compile, let me clear the screen, java. Okay, we have this error saying non-static variable age1 cannot be referenced from a static context. Yeah, I told you something about static variable and static. Now what it says cannot be referenced from a static context. Static context means a static block. Okay, saying a non-static variable age1 cannot be referenced from a static block. That is in line 10 in the modifier example. Now in modifier example, okay, in line 10, Now, whenever a method is declared static, okay, every variable that is declared outside the method must also be given the static modifier. Like here, it's saying that age 1 cannot be used here because it's not declared static. So I'm going to put static here. Okay, that should resolve the issue. I'm going to compile. I expect to see another error. Yes, I expect to see this error saying that in modifier child is now we're going to modifier child the driver in line 3 error. Compute average in modifier child cannot be override compute average in modifier example because overriding method is static. The overriding method is static. So this method is the overriding method and this is the overriding method. So because it's static over there, we must also declare this to be static. Alright, so let's go back again to our program and compile again. Java. Great, everything works well now. So we're going to execute. We have no output. Okay, that's because we really didn't print out anything here. So yeah, I could go like modifier 1 dot compute average. Okay, so that should clear the screen, or I expand it a little more. Okay, so that's the output. The average age of 36 150 is that. Okay, now why do we put this static here? Another reason is like we did before, that we can actually call this method using the class name. Okay, so I can come in here instead of using the object's name that was created from the class. I can actually do this modifier child.compute average. Okay, now I can come in here and compile. You see that? Wait, then good. So the average age of 36 150 40 is 75.33, like we have in the previous example that we compiled. Now you will observe that here I use the class name to execute the object name, but if the static isn't there, that will be an error. Okay, if this is not there, now if we compile, we will have an error because we are extending this class, and in this class the compute average is having a static modifier. Okay, and I will have to remove this from here also, and then because there is no static here, okay, there will be no static here. That will go fine. And here if I save this and then we try to do this to compile and execute again, we don't have an error saying non-static method, this cannot be referenced from the static context. Again, complaining that this is a static method. Okay, static method, and this is not a static method, so that is why we have to put static here. And then yeah, so that this class override this class, there will be static. And also this will not be possible because this would not be possible if there is no static modifier for the method. Okay, all right. So because we have static modifier for this method, we can actually execute this method using the class name. Now I want to come back to this main method to explain what is actually happening here. Whenever you try to say when you compile a Java program like this, okay, and it compiles and gives you let's go back to this place, modifier main.class. Where is the modifier? Main modifier, the main modifier.class, this is it here. Okay, when we compile this source file, we get this class file. Okay, now whenever we invoke the JVM and say, hey JVM execute java.main modifier.class, okay, we are actually invoking this class to be executed, main modifier to be executed. And what the JVM will do is that it's going to look for main modifier.main. Okay, it will want to execute this main method. So it's going to call JVM. JVM will be invoked by this command Java, and when JVM is invoked, the JVM will try to call main modifier dot main. Now that will only be possible if main has a static modifier. That is why static must be here. Okay, now without a static modifier, the JVM will try to do main modifier dot main and to return an error because main does not have a static modifier. That is why static must be here in your main method to be executed by the JVM. I will explain more in our WhatsApp group if there is any confusion you have, and then of course if you have any question we would discuss that in the WhatsApp group. So very important, we have our static modifier for our main method in Java, so that the JVM will be able to say main modifier dot main, like we have it here, modifier child dot compute average. Yeah. All right. So that is static. What would you say this? Static can only be given to a method and a variable. Okay, we don't have a static class. Okay, we don't have a static class, but we can have a static inner class. When we go to inner classes, I'm going to discuss static inner classes. Okay, so that is static modifier. I hope it's clear. If you have any question, you can leave it in the WhatsApp group and I'm going to attend to your questions. Okay, yeah, we're through with the static modifier. Now I want us to move to the abstract modifier. Now abstract modifier is used to refer to modifiers that don't have a complete body, that the child is going to the subclass is going to implement. What I mean is this. Now here we have a method, okay, and then here we have a method in this class, modifier example, and here we have the modifier child extends the modifier example. Now here, if I want to say I want to declare a method, for instance, say I say public. I'll give an example very soon after I explain this. If I say public void compute sum. Okay, now look at this. Because this is a method, why? Because it's having open and closing brackets, and here we have void here. Okay, but you observe I have semicolon here, and normally for a method you should not have semicolon. What you should have after a method signature is the block for that method. But in this case, I don't want to have a block here. I want this class to be extended, okay, and I want the subclass to define this. In doing this, I will have to put abstract there. Okay, now so if a class have one or more abstract method, then that class must be declared abstract. Okay, when a class has one or more abstract method, that class should be declared abstract. Okay, now this example comes into play when we are dealing with either animals or employees. Okay, yes, still give an instance of an employee in an organization. We have different employees in an organization. You have the sales manager, you have the sales representative, you have the HR, you have the admin and other stuff. Now we can have a main class called employee, okay, and we could have some things defined for that class employee. Now there are some specific things that we can't really define for employee, which will be defined by each employee or for each category of employee. Say for instance salary. Now we cannot begin, we shouldn't define salary within the class employee, because different employee have different salary, or salaries for different employee are computed differently. So such a method like compute salary will be given an abstract method and declared like this, so that the admin employee class will extend the employee class and implement the compute salary, and also the HR employee would also extend the employee class and also do what? Implement the compute salary. Okay, but for our example here, we have the modifier example. Here we have compute sum, and of course we have an abstract class. Okay, so in our subclass here, I will do this, or I should even copy your signature. So here I will now define the compute sum. Alright, so say system dot out dot print line, or before that let me compute the sum. Let's say int age, int age, come on, int age sum is equal to age 1 plus age 2. So we're like age 1 plus age 2. Alright, so here I would say the quote the sum age, or let me use that interpolation again, the sum of age 1 and age 2 is okay, I'll go like age 1 comma age 2 and age sum. Okay, and then you print ln, I'll use a print f. Okay, so system dot out of print f, the sum of this and this is alright. Now, so this class extends this class is an abstract class, okay, defined here because it has an abstract method which we defined in this place, compute sum. Okay, so if I have another class, maybe I have modifier child 2 extends modifier example, I can then come ahead to say public, oh, there should be no more abstract here, public void compute sum, and I can compute a different kind of sum for that class. Okay, alright, so here alright, so I'm going to compile. If everything goes well, let me clear the screen. CLS, so do like javac okay, we have an error. Oh great, no error. We need to execute this method. Excuse me. Okay, let me comment this out. Okay, you can call this method. I'm going to go like this. There. So go like modifier 1 dot compute sum. Okay. Alright. So alright, so let's go ahead and compile now and see. Compile again because we made some modification. Then let's execute. Alright, so we have the sum of 36 and 40 is 76. Okay, now to show off again how this abstract really works again, say I have another class. I'm just going to copy this from here, Ctrl-C, and paste here, call it modifier child child, and that modifier child. Okay, I don't need this here. Okay, just want this method, and here I will say the sum of this and this, I'm going to multiply it by 2. Multiply by 2. Okay, then I say the sum of this and this multiplied by 2 multiplied by 2 is that. Okay, so I'm going to save this as modifier child. See, modifier child.java. Okay, so we have modifier child extend modifier example, modifier child also extend modifier example. Good. So both classes are extended modifier example, and they both implement the abstract method defined in modifier example. Okay, and here for modifier child we say let the sum be multiplied by 2. All right, so one interesting thing is the fact that this main class or superclass, that is where we have age1 and age2 defined. Okay, it's not defined anywhere here, neither is it defined anywhere here. Okay, but it's defined in this class. So we can say that modifier child and modifier child2 has inherited these two variables. So this is what is called inheritance in Java, basically. Okay, inheritance in Java. Okay, as well as this modifier child has also inherited this method also, compute average. Has also inherited the method. Okay, so I'm going to come in to our main method and say modifier child child. Okay, or let me not spoil this. We'll declare that one here and call it the modifier child 1, modifier child 1, then I'll call it modifier child. Okay, so I'm going to go like copy this from here, proceed, modifier child 1, we have modifier 1 and modifier child 1 coming from modifier child. I was saying compute sum. Okay, so I'm going to save this, then let's compile and see our output. Okay, we have an error somewhere. The incompatible type modifier child cannot be converted to. Okay, oh, look at this here. Is if you look at the error, and it's coming from line 23. I know the reason is because we are having this. Okay, so let's save this and compile again. Alright, no error. Okay, the sum of the 36 and 40 is 76. The sum of 36 and 40 multiplied by 2 is 152. Appearing on the same line. That's because in our modifier child, after printing this, I should have done this. \n. My keyboard is quite funny today. I don't have \n on my system. Okay, let me use the on-screen keyboard. Then I'm going to use I need the \n. Alright, this is it here, \n. That's all I need. Okay. Alright. So compile again. Yeah, that is it. So the sum of this is two numbers is this, and the sum of these two numbers multiplied by 2 is 152. Okay, so we see the fact that an abstract method can be declared within a class. Okay, that will be implemented, or that will be completed in the subclass, like we did here, or like I've just done. I've shown you. Okay, now one interesting thing about an abstract class is the fact that you cannot, or you should never try to instantiate an abstract class. Okay, an abstract class is just meant to be a superclass. Say if you try to do this, if you try to say modifier n is equal to new modifier, okay, there will be an error like this. Okay, let's see. Yeah, modifier example is abstract, cannot be instantiated. Okay, so abstract class should never be instantiated. Okay, abstract class should never be instantiated because they are meant to be superclasses, and they are meant to be extended by other classes to finish all the declaration. So whenever a class has an abstract modifier, it should never be instantiated, and it should be extended, and the subclass should implement the abstract method. Yes, so only a method and a class can be declared abstract. Okay, a variable should not and cannot be declared abstract. So now if in this place we omit this, we don't declare this, or say in this place modifier child, and I remove this from here, let me comment this out. I just want to show you something. If I comment this out, okay, meaning that compute sum is in there. Compute sum is an abstract method, and we say, hey, let this class extend this. What this means is that the contract here is that this modifier child will implement all the abstract method in this class. So if this class does not implement the abstract method or implement all the abstract method, this class should also be declared abstract. Okay, meaning that this class should not be instantiated, and that means another class should extend this class and implement the abstract method. So if we go ahead and compile our program, because we have let me take this from here, we've seen this already, modifier child modifier 1, and we'll try to compile this. We should have an error because another error saying that what modifier child modifier child is not abstract and does not override the abstract method compute sum in modifier example, okay, in line 1. So this class, since it's not implementing this method, that means that this class should also be declared abstract. Okay, now when this is declared abstract, meaning that this class should not be instantiated. Okay, it should not be instantiated because it's now declared abstract. That means that if we compile again, we will get an error. Okay, because like we saw earlier, abstract classes should not be instantiated. Okay, cannot be instantiated because the modifier child is an abstract class. So if I now do this, so modifier child extends modifier child. Okay, meaning that it's extending this class. So this class extends modifier example, and modifier child extends modifier child extend modifier child. And in this class we did what? We implemented the abstract method, so this should not be declared abstract. So that means that this line should go, this one should not be there, and this should not also be there. Okay, because why? The modifier child is an abstract class, but the modifier child is a normal class. So doing this, we'll fix the error, and when we compile, everything should go well. That's it. Okay, and the interesting part again to it is the fact that if you look at this class, we don't have this method called compute average, and in this place we can actually say modifier child compute average, modifier child 1 dot compute average. Okay, because this compute average method is coming from the superclass modifier child, which is this is it here, modifier compute average. Okay, so if we save this, and again compile, we have an error somewhere. Line 26, Java modifier Java line 26, modifier Java main modifier line 26. What's the error? It's saying that modifier error cannot find the symbol modifier child 1 line 26. Okay, Java is case sensitive. Here we have modifier child C. The C is lowercase, the C is uppercase here, so I have to fix that. So it's just case sensitive. Java is case sensitive. Oh, my system is battery is going low. I'm going to stop the tutorial here and continue let me just run this example, then I'm going to pause the tutorial, then continue on a later time. Okay, okay, so there we have it. The sum of 36 and 40 multiplied by 2 is this, and the average of 36 and 150 and 40 is this, coming from this part is coming from here. Okay, superclass, which this class extended. Alright, so that is it about the abstract modifier. So we're through with the abstract modifier. I'm going to take a break now. When I return, I'm going to finish up the rest of the modifier. Alright, hang on.